Hello students, we have completed module number 2 and this is the video lecture that revises the module number 2, that is the geometric design of highway. Right? In geometric design of highway we have learned various geometric designs or geometric properties of the highway, and that content let us consider one by one here. So side distance are considered in geometric highways are stopping side distance and overtaking side distance. So here in stopping side distance we have studied that Vt plus V square by 2 Gf, that is Vt is the lag distance and V square by 2 Gf is the braking distance. Lag distance is based on the time, that is the reaction time of the driver and speed of the vehicle, and similarly for braking action is considered, the frictional force is considered in this equation. So lag distance plus braking distance, that will equating to the stopping side distance of the vehicle. In this equation or in this formula, the Indian Road Congress has been given that time of driver that reacts for the action is considered to be 2.5 seconds, and frictional force in longitudinal direction is considered to be 0.35, and in longitudinal direction it is 0.15, and G is considered to be 9.81, and the whatever the formula is written here, in this formula V is equal to speed of the vehicle in meter per second. In meter per second it is has to be substituted, and once we substitute the value of this and V in meter per second, you will be getting with the stopping side distance of vehicle. Similarly, the overtaking side distance is also discussed. Here the overtaking side distance d1, d2 and d3 is sum up, and distance d1, distance d2 and distance d3 are corresponding to the vehicles, overtaking vehicle, overtaken vehicle and the vehicle which is coming on opposite direction. So d1 is a distance between overtaking vehicle and overtaken vehicle before the actions takes place, and d2 is the distance between actual overtaking operation of vehicle A, that is considered in the analysis, and d3 is the distance traveled by the vehicle C during the actual overtaken operation of vehicle A. Right, you might have remembered this. And distance d1 can be calculated using velocity of vehicle B. Vehicle B is nothing but overtaken vehicle with reaction time of driver. And here in this equation the reaction time of the driver is given with 2 seconds, and Vb is the speed of overtaken vehicle, and d2 is 2s plus Vb into t. Here t is not given because the time is dependent on many factors, that is the speed of overtaken vehicle and acceleration of overtaking vehicle and gradient of the pavement. Right, all the factors are depending, so that this t is can be calculated by 4s by a is the acceleration. Similarly, here s is 0.7 times of speed of overtaken vehicle plus length of the vehicle, that is 6. We can consider 6.1 also, but it is better you consider 0.7 Vb plus 6, and d3 is V into t. V is the speed of overtaken vehicle or the vehicle which is coming on opposite direction, and t is similar as this one. T is under root 4s by a. Whenever sometimes the Vb will not be given, in that case the Vb is considered V minus 4.5 meter per second, and here V is also in meter per second. Whatever now I am discussing here, these are all concerned to speed in meter per second only. If it is, unless the speed is not in meter per second, I will intimate, I will say that whether V is in kmph or not in upcoming geometry. Right, and here this much analysis has been done in the overtaking side distance. Here it is needed to remember d1, d2 and d3 formulas, and S values. Apart from this, the value of A, acceleration coefficient value, will be given sometimes. If it is not given, we have to remember that table that is considered in the lectures of problems on the overtaking side distance. And next geometric condition, we have considered super elevation. That super elevation is considered to be E plus F equal to V square by GR on full condition. Some cases for mixed traffic condition, we might have considered E equal to 0.75 V whole square by GR, right? So here 0.75 V is considered to be 75% of the speed is considered in mixed design, or in mixed design in the sense mixed design traffic. And here E is restricted to 7%, or you can say 0.07, and F is a lateral friction 0.15, because whenever the super elevation is considered, the centrifugal force will tend its body to move sidewise, and this sidewise movement is considered to be lateral friction. The value of lateral friction recommended by code is 0.15, and E plus F equal to V square by GR. And we all know that to calculate this super elevation, we have different steps. In first step, we need to consider mixed traffic condition. Later, we need to check whether this mixed traffic condition is lying with 0.07 or less than 0.07. If it is lying with less than 0.07, you can go with the obtained value. If it is not, we have to consider next step, that is considering F frictional value, and then taking this value as minus E here. F equal to V square by GR minus E, that is the second step, and then calculate for F by substituting the full value of E. Once you get F value, that should be less than this 0.15 or equal to 0.15. If it is more than 0.15, then we have to restrict our speed by substituting E and F as 0.07 and 0.15 respectively, so that we can restrict the speed on the particular pavement. And this is what the analysis is being considered in the super elevation. Similarly, the next geometric condition is considered, that is extra widening. In this extra widening, mechanical and psychological widening is being considered, because the rigidity between wheelbase is considered for the vehicles, and psychological condition of the driver is also an important factor here. So WE is the total extra widening, that is mechanical widening, and psychological widening. Mechanical widening is NL square by 2R, and psychological widening is V by 9.5 under root R. So here up till super elevation, we can consider V in meter per second, so that you can completely go with this equation. But in extra widening, this formula is been recommended by Indian Road Congress, and this recommendation is given in V kmph. So that we need to consider V in kmph for this extra widening. For psychological widening, that is N is the number of lanes on the highway, and L is the length of vehicle, and R is the radius of the curve, which is less than 300 meter, and V is the speed of the vehicle, and here R also the radius of curve. And next geometric design is setback distance. The setback distance is considered for single lane road and double lane road. Whenever single lane road is there, then R will be its full length, and R minus R cos alpha by 2 will give you the total setback distance when the length of the sight distance is considered greater or equal. And whenever there are two lanes, we can consider this M equal to R minus D cos alpha by 2, and here alpha by 2 in radians you can consider by degree by considering 180s by pi r. And here the length of transition curve is also discussed as another geometric property. So here in this case we have been given with three conditions. First one is rate of centrifugal acceleration, and the first one is rate of centrifugal acceleration of the vehicle, and second one is rate of introduction of super elevation, and third one is by empirical formula given IRC. So here first one is considered to be VQ by CR, that is centrifugal acceleration. This C value is considered by 80 by 75 plus V, and again V is in kmph here, we need to remember this. V is in kmph and 0.5 C, and that means C will be greater than 0.5 and less than 0.8. And here for second condition, rate of introduction of super elevation E plus E into W by 2 into N. When W by 2 is considered, the pavement is rotating about its center, and EW into N it is considered, then the pavement is rotated at its center, that is at the inner part. And here N is the value of plane, that is in build-up area or in hilly areas or in plain areas. Plain areas it is given with 150, in build-up areas it is given in 100, and in hilly areas it is given with 60, I think, right? And these formulas are, these values have to be remembered as a N value, right? And we have to substitute here, and the W is considered to be extra widening plus actual width of the pavement. These are all substituting, hence we'll get the length of transition curve by rate of introduction of super elevation. And similarly for empirical formula is given plane and rolling terrains 2.7 V square by R, and V is in kmph here, meter per second here, and also steep and mountains it is given as V square by R, and here V is also in meter per second. We can consider the shift, that is Ls square by 24R. Once we calculate this Ls, that is the length of transition curve, the maximum obtained value is to be considered as the length of transition curve, and that length of transition curve is substituted here, then you will get that shift S. And summit curve is, and vertical curves. So vertical curves are stopping side distance and overtaking side distance is been considered to decide the length of particular summit curve. And in first case, you can consider length is greater than stopping side distance, then Ls will be Ns square by 4.4. And this 4.4 is considered by considering the height of the driver eye and height of the headlight of the vehicle. And L is less than stopping side distance, then you can consider 2S by 4.4 divided by N. Similarly, in second case, for the overtaking side distance, L is greater than overtaking side distance, you can have N square by 9.6, that is 8H. And here L is less than overtaking side distance, that will be 2S minus 9.6 N. And similarly for valley curve, you'll be having two cases based on centrifugal acceleration, that is C. The value of C is given by 0.06 meter per second cube, that has been considered, and headlight side distance is also considered as one of the case. And in centrifugal acceleration, you can have L equal to 2 into NVQ by C to the power 1 by 2. And in headlight side distance, you can have two conditions again. L is greater than stopping side distance and L is less than stopping side distance. Once we know the values, you can substitute the deviation angle and stopping side distance, and here also stopping side distance we will be getting with the total length of valley curve. And again similarly here we have to consider the value of N here. It is only N, 1.5 plus 0.035 S divided by N. N is the deviation angle. And this much the geometric design is considered in the second module, and the value of recommended by IRC is to be remembered. So once we remember these formulas, we can easily go with the problems that will be considered in the particular geometric design. So in this class, by this class I will end up with the second module. In next class I will start with third module. Thank you.